Okay, we're going to look at the unit circle and the trig definitions, how they change when you're on the unit circle. So, the unit circle. So what we mean by unit circle is that the radius is 1. Okay, that's all that means, is that the radius is 1. So if we draw a unit circle, it looks like this. And if the radius is 1, if we name some of these coordinates, then this would be 1, 0. Up at the top here, this would be 0, 1. Again, since the radius is 1. Coordinates here would be negative 1, 0. And down here at the bottom, we'd have 0, negative 1. Okay. Now, the reason why it's nice to look at a unit circle is because when you look at the definitions of the trig functions, they simplify quite a bit when the radius is 1. That is, if we take a look at sine of theta, for example, the sine of theta, the general definition is the y-coordinate divided by r, the radius. Well, on a unit circle, since the radius is 1, we'd have y divided by 1, which is just simply y. So on the unit circle, then, we can say that the sine of theta is equal to simply whatever the y-coordinate is. Likewise, the cosine of theta is the x-coordinate over r, which would leave us x over 1, again, since the radius is 1 on the unit circle, which is simply just the x-coordinate. So again, the cosine of theta on a unit circle is simply x. Tangent of theta we don't get any breaks on, because if you recall, tangent of theta is the y-coordinate over the x-coordinate, or y over x. And since the radius is not involved there, we don't get any simplifications. And of course, the three reciprocals would be likewise here. The cosecant of theta would be 1 over the y-coordinate, the secant of theta would be 1 over the x-coordinate, and tangent of theta, x over y. We're going to focus on these three right now. So let's give this a try then. Let's mark off our angles here. That is, if I look straight up here along the positive y-axis, this would be an angle of 90 degrees. If I go over here to the negative x-axis, that's 180 degrees. Down here is 270 degrees, and back to where we started with was 360. If we think about radians instead, of course this is 0, and up here at the top at 90 degrees, that would be pi over 2 in radians. At 180 degrees, that would be pi radians, approximately 3.14 radians. And down here at 270, that's 3 pi over 2 radians. And then back around to where we started again would be 2 pi radians. So looking at just the coordinates there that I've marked, let's take a look at what is the sine of 90 degrees. So the sine of 90 degrees is the y-coordinate, just simply the y-coordinate on the unit circle, since the radius is 1. So the sine of 90 degrees is the y value, which is just 1. So the sine of 90 is 1. Let's try that again. The cosine of 270 degrees. Okay, so I'm looking at my unit circle, looking at an angle of 270 degrees, looking at just the x-coordinate, and the x-coordinate is 0, so the cosine of 270 is 0. Okay, we'll try this again. How about tangent of pi over 2? Okay, so pi over 2 is 90 degrees, it's straight up, and tangent is the y over x, and so y over x in this case would be 1 over 0, but division by 0 is undefined. So the tangent of pi over 2 is undefined. You can check that out on the calculator. If you put your calculator in radian mode and hit tan pi over 2, it should give you an error. One more, let's try the cotangent of 3 pi over 2. Okay, so I'm looking at my unit circle, spin around to an angle of 3 pi over 2. I see my coordinates are 0 and -1. That's x over y this time. My x coordinate is 0. My y coordinate is -1. 0 divided by -1 is 0. Okay, now we're going to focus on the special angles that are in the first quadrant. And as we've seen, if we know what the coordinates are on the unit circle, for a given angle, then we can simply write down what the trig functions are because they're all defined in terms of x and y. So let's see then what those coordinates are for the special angles. Now the special angles we're going to focus on, of course, are pi over 6 in radian modes, which in degree mode is 30 degrees. We'll look at pi over 4, which is 45 degrees. And we'll also look at pi over 3, which is the same as 60 degrees. Okay, so right now, as I said, we're going to focus on these 3, which are in the first quadrant, and then in the next video, we'll take a look at how to deal with these angles when their multiples are outside of the first quadrant. Okay, so I'm just going to simply write down what these coordinates are for these special angles in the first quadrant. If you're interested in where these numbers come from, you can reference another video called Where Do These Numbers Come From for the Special Angles. But right now we're going to take them as given. Okay, so first coordinates we're going to talk about are for a pi over 6 angle, or 30 degrees. And the coordinates for that, square root of 3 over 2, comma, 1/2. And again, if you're interested in where those numbers come from, then take a look at our listing for another video that would tell you where those numbers come from. Now I'm going to spin up here to 45 degrees, or pi over 4. And the coordinates here are square root of 2 over 2 and square root of 2 over 2. And the last one we're going to look at is an angle of pi over 3, or 60 degrees. And those coordinates are the same as the first ones we wrote down, just reversed. That's 1/2 and square root of 3 over 2. Okay, now before I move on, I'd like to point out one thing here. All of the denominators are 2, and if you look at the numerators, you can count from 1, 2, 3, going from the y-axis down, and then if I go back up on this side, they increase 1, 2, 3. So all the denominators are 2, and then as I said, if you start up here at the top and then look at the numerators coming down, it's 1, 2, 3 on the left-hand side, and then going back up this way, on the right-hand side, the numerators are 1, 2, 3. Now, my claim is that these are the only 3 coordinates that you have to memorize to know all of the special angles inside the first quadrant, outside the first quadrant, wherever your special angle may be. But right now we'll just focus on these. So if I know these coordinates, then I can answer things like, what is the cosine of pi over 4? Well, the cosine is the x-coordinate on the unit circle, and so I simply look at what the x-coordinate is, and it's square root of 2 over 2. If I would like to know what is the sine of 30 degrees. Okay, so 30 degrees, that's the same as pi over 6. The sine is the y value, and so the sine of 30 degrees, looking at my coordinates there, is 1/2. Let's say the tangent of pi over 3. So the tangent is the y-coordinate over x. So let's see, the y-coordinate over x for pi over 3 would be the square root of 3 over 2 divided by 1/2. Now I don't want to leave that like that, so let's simplify by multiplying by the reciprocal of the denominator. So that would look like the square root of 3 over 2 times the reciprocal of the denominator, 2 over 1. The 2's cancel, and I simply get square root of 3. Okay, the reciprocals work the same way, although I kind of tend to think of, well, let's just do an example here. How about the cosecant of, let's say, pi over 6? Okay, so cosecant is the reciprocal of sine, and I know that sine is y, so that would mean that the cosecant is 1 over y. So for our example here, it would be 1 over the y-coordinate for a pi over 6 angle is 1/2, and so 1 over 1/2 is just 2. Okay, we'll do one more here and then move out of the first quadrant. How about the cotangent of 60 degrees? The cotangent is x over y. Let's see, 60 degrees have the 1/2 square root of 3 over 2 coordinates, so that would be 1/2 x for the y, or for the x coordinate, and for y we have square root of 3 over 2. Again, we don't want to leave that like that, so that's 1/2 times the reciprocal of the bottom. The 2's cancel, and I get 1 over the square root of 3. If you're looking in your book and you're saying they don't have that, it could be because they rationalize the denominator. If you rationalize the denominator, you'd multiply by the square root of 3 over the square root of 3, which simplifies to the square root of 3 on top, and then the square root of 3 times the square root of 3, square root of 9, back to 3 again. Okay, so however it is that you need to express your answer. Okay, I think we're ready to go out of the first quadrant.